Welcome to qnawire.
So to keep the system in an horizontal plane, we need to put all the vertical forces equal to 0. So vertical forces must sum to 0 to keep that in horizontal. Now omega here is the shaft rotating in an horizontal plane. So that's shaft rotating in horizontal plane. And we know that this is equal to torque over the angular momentum, because angular momentum times omega gives us the force that's acted on the system. And torque here is the weight, W times R, and the angular momentum here is I times omega, where omega is the angular velocity of the tire or of the bicycle wheel. So from there, as we mentioned, that this vertical forces must be equal to 0. So let's look at the upward forces that's acted on the system. So there are two upward forces by the hands. One is FL and one is FR, where R is the right hand and FL is the left hand force. So torque will be the difference between these forces times the radial vector, which is R, and in our case R is 0.2 meters, so that gives us the torque. And also there's another condition, which is the total weight of the system must be equal to the upward forces by the hands. That's why we have set the weight of the system equal to the total vertical upward forces. So using these two equations, so we wrote this equation over here again, and we saw that FL minus FR gives us torque over R, where torque, the expression for torque can be taken from here, where torque is L times omega and L is I times small omega. So that gives us I times small omega times big omega over R. And if we combine these two equations, we see, first of all, we compute W, which is mg, and that's 78.4 newtons. And also we compute I omega over R, which gives us 132.7 kg meter per second squared. And using these two equations, now we solve for FL and FR. All we gotta do is add these two equations to get FL and subtract these two equations to get FR. So if we do so, we see that FL is this expression right here, and then there's this omega, big omega term. Also we have FR with the big omega term. So we wrote these two equations over here as well, so that it's easier to visualize. Now for part A, our big omega is 0, or the shaft is at rest. So in that case, this part goes to 0, so all we have is this number. So that means FL is equal to FR, which is equal to 39.2 Newton. For B, we have the shaft rotating velocity as 0.05 revs per second. So omega in our case is 0.05 revs per second. We convert that to radians per second, and that gives us 0.314 radians per second. And then using this value over these two expressions, we see FL is equal to 60 newtons and FR is 18.4 newtons. Part C, we have omega as zero point 0.3 revs per second, which is 1.89 radians per second. So using that, we see FL is 60 newtons. Sorry, FL is 165 newtons, and FR is negative 86.2 newtons. And this negative sign means that the force is downward. So this is downward. So that's the significance of the negative sign. And in the final part, we must support the shaft with one hand. So that means force on the other hand should be 0. So we set one of them equal to 0. Then that gives us omega being equal to 39.2 newtons divided by 66.4 newton seconds, which is equal to 0.59 radians per second. And if we convert that to revs per second, this is 0.094 revs per second. Thank you.